Okay. Right. So somehow I have to make amends for the fact that I said that Java was not an interesting language. No, I'm not going to make amends. We're going to go with it. We're going to own it because actually that's kind of one of the things. Java is kind of a very consolidated language, and this idea had been kicking around for a few years. Trisha was one of the people that I kind of thought of like, yeah, you would be great for this book. 97 things every programmer should know is something I did many years ago. But I thought, we should get more specific. Choose something that's got a really well-defined space. And it eventually happened. It took longer than expected. But thanks to the pandemic, we finished the editing it kind of in the first wave of pandemics, I think.
It was released in June 2020, I think.
Yeah.
So we had originally planned to do this session at GOTO Amsterdam in 2021.
Yeah.
So here we are, 3 years later.
Here we are, yeah.
Yay!
Wrong city, wrong year, but damn it, this is software, so it's exactly right.
But it also fits really nicely with the theme of 97 things, because I think there was a slight extrapolation there that we would tell you things which are going to make you a good programmer. No, it's just 97 things. And we just turn up and do some things, and the book, it happened when it happened. And
indeed.
It's a bit like life, isn't it?
It is, yeah. So, you have the power. You have the power
right.
At this point. Okay, So there we go. That's the whole thing. That nice title that rolls off your tongue. I guess the whole. So just to, I'll head off the question that we always get asked: why 97? Because it's a strong prime, obviously. Why else? No. Because originally the first book in the series was done by Richard Monson-Hafel, and it was about software architecture, and it happened on a group, and he sort of said, there's a lot of really good suggestions here. He wanted 10 things a software architect should know for a talk. And he said, people are making so many good suggestions. He said, there's a book here. I think I need about 100, but we can't do 100 because that's too obvious a number. And we can't do 99 or 101 because they're obviously trying too hard not to be 100. Hi, I'm 99. Oh, am I next to 100? I didn't notice. But 97 is about 100, but it's not trying to be 100. It's cool. It's its own thing. So, and anyway.
But the thing that gets me about that, though, is now we have to spend the whole time explaining why we picked 97, and perhaps we should have just picked 100.
Yeah. And one of the hardest things is sometimes, and Trisha and I hit this when we went through the selection process, so I think the next slide gives us something. There's people. There's
people.
Items. So first of all, here's 97 things. We'll get to the people in a moment. But here's the 97 things. And so...
you can all read that from back there, can't you?
Yeah, I hope so. This is an eye test. So we've got 97 things. As you can tell, we chose the most rational system of organization, which is alphabetical, because it turns out that when you try and do this by theme, everything crisscrosses. And we managed to get a whole load of people involved. So that will be the next slide. 73 people. So again, power laws. I talked about power laws this morning, but it kind of works out like that as well. Some people submit many things, but most people submit one. And when you go through, there's a really broad range of people. So it was a lot of really good ideas, and more importantly, these are not ideas that either of us would necessarily have come up with. What I love about this is sometimes you're reading something that you know, and you go, I'd never have thought of that. I would not have thought about, and this is a much fresher approach. So that's one of the most important things. And if you become a good programmer through it, well done.
But one of the other important things was that intentionally there are some things which contradict each other. Because as you all know, good software is all about the trade-offs and the it depends. And two different things can be true at the same time. And so we had some pieces which were submitted which contradicted each other, and it was great to have them in. And we had some pieces where we were like, well, we would actually quite like a contradictory piece to this. And we would go out and find someone who could give the other side of that conversation.
So we're offering you, we're not saying here is the answer. It is not 97 things that we have mandated. It is 97 from actually a larger selection that we think fit well together because they provoke the right conversation. And particularly with some matters in software, we can't say, that is the answer. It's actually, there's a discussion here. So we're going to show you two sides of this so you are presented with that. So sometimes I have had that criticism about the 97 things every programmer should know. It's just like, you've got ideas in here that contradict each other. It's just like, yeah, welcome to software. Okay, so that was intentional, but we wanted to capture that diversity. The problem, though, with hard coding 97 in is that there are some people we weren't able to include. The hard decision of we're down to like 99 or 100, and it's just like, we've got to trim it because it's hard-coded.
And Jean submitted 6 great pieces,
Oh,
and we were limited to 3 pieces per author. And we were like, we're just going to have to close our eyes and pick 3 because they were all excellent.
Yeah.
Mind you, there were some pieces where we were like, we don't agree with that. We're not putting that in.
Yeah, there was some. Yeah, it's just, this is so wrong that no, we don't want that out there. So, should we talk about?
I clicked it, but it.
There we go. And it turns out that we don't just have me and Trisha in the room, we have Holly and Emily. So what we're going to do is we're going to present some of the items, and we're also going to have Holly and Emily present one of their items each. We had hoped to have Dave, but he's at an airport right now.
Rude, honestly.
It's just rude. Honestly, airports are not as exciting as GOTO.
Really are not.
So this is a much nicer space. So we're going to do that one.
We're going to be Dave.
Yeah, we're going to be Dave. Then I'm going to do one of yours. You can do one of mine. And and then the excitement. You could be the proud owner of one of these.
We have 2.
We have 2.
2 to give away. Is that here? Yes.
There we go.
Right. So take a look. QR code will take you to a form. Put some name in, which is hopefully your name. Ideally, a unique, identifiable name, because if your name is Dave, probably 6 people will go, I'm Dave, I want the book. So put your name in. And at the end of this talk, we will live randomly draw 2 winners, not winders. So you have to stay to the end of the talk, and I will give you your book. And if you ask really nicely, we might even sign it, don't you think?
Yeah.
Probably should have done that beforehand.
I don't know. And I'm giving you an option on that.
Yeah, because you might be like, no, I don't want to sign
don't
that.
touch my beautiful book.
Right, so yes, everyone seems to have done that.
Yeah,
Cool.
right.
Great. Oh, it's me.
It's you. Right.
Awesome. Okay. So everyone will be totally shocked to learn that I'm going to talk about the IDE. And actually, if you came to... Well, is this going to work? Please let it work. Right. If you came to my session yesterday, this is basically the same thing. So in order to reduce the sort of live demo cognitive load that I need to present and talk at the same time, I'm actually just going to play it as a video. The keyboard shortcuts do come on the bottom, but it's not necessarily about teaching you specific keyboard shortcuts for the IDE, particularly if you're not a Java programmer and you don't use IntelliJ. The point about this piece from 97 Things is to encourage you to use IntelliJ and maybe buy my other book as well. But the idea is that if you know your IDE, if you know your tools, then you don't have to think so hard about all the boring stuff. I mean, we can make the same argument these days, maybe for AI. Well, that's a conversation for last night's panel. But when you know your tools, when your fingers can actually do the things without you thinking about it, it allows you to focus the full power of your brain on the thing you're trying to actually solve. So it allows you to think about, what does the business really need from this? What are the trade-offs that I'm making while I make these decisions? And I don't have to be thinking about, where was that menu item to create a brand new class? Or where do I need to go to find one of these things? I don't have to think about that because I've invested some time in learning how my tools work. I've trained my fingers on the keyboard shortcuts I use most regularly. I've created custom live templates like I have here to generate tests the shape that I want my tests to be in, so I don't have to go, oh my God, I have to type given when and then again. So if you learn your tools and customize your tools to your needs, the needs that you do all the time, because of course, something like IntelliJ has like so much functionality you will never use, but learn the 2% that you're going to use all the time so that you can focus your full attention on thinking about the problem you're actually trying to solve. So as a kind of summary of some of my favorite things about IntelliJ, and I talked about this in my talk yesterday as well, in terms of editor features, my favorite things are probably Alt-Enter, because it will do everything for you. Live templates, whether they're the built-in live templates or a custom live template to create the test that I want. And something else that I can't remember. You can't see my speaker notes in here. Live templates, Alt-Enter, and all the other stuff the editor does. But it's not just about writing code, because as we've discovered throughout this conference, writing code is not the large part of what we do as developers. We also do things like finding problems in our code and doing other stuff. So the running and debugging is like super fundamental as well, because I need to be able to see how it runs and step through things and step back if something goes wrong. Understanding the debugger of your IDE is a surprisingly, how long have debuggers been around for?
Forever.
Forever.
Pretty much,
And
yes.
yet there's still quite a lot of developers who don't really understand how to use their debugger. So invest some time in learning how to use the debugger, how to step into, how to step over, how to evaluate expression, how to drop frame. Those things will really save you a lot of time when you've got some weird bug and you don't know what's going on with your system. And then the other aspect about an integrated development environment is the integration points. So for IntelliJ IDEA, for me, the key integration points are integration with Git, because no one really understands how Git works. They just kind of wave the magic incantation to do the thing they do all the time. But the IntelliJ IDEA Git support is pretty good and can give you a decent overview of where you are and what you've done. So the Git support, build tool support. I work for Gradle these days, but the video I did for how Gradle works in IntelliJ IDEA is one of the most viewed videos for IntelliJ IDEA, because the build tool support, dependency management is super key to making sure that your code works the way you want it to. Well, the video stopped, so it's probably time for me to finish. If you want to find out more about the IDE, read this book and buy my other book.
Awesome. Right, so I'm going to pick up, actually, so Trisha just showed you the idea of templates and therefore the content of your test. But let's talk about the broader structuring. So I want to look from the outside. So one of my pieces is program with guts. And so you're writing unit tests. If the answer is no, stay quiet. Great. Are they any good? That's the second question. People often don't ask that. Because do you have guts? Guts is a term from Alistair Coburn. Very many people say TDD when they really mean I have good unit tests. I have guts. The point that Alistair was making was that in many cases people are reaching for the nearest word for thing to do with testing that shows that we're doing it better. And TDD is a workflow. But guts are the thing that you will commit and you will see. The next person will see that. They might not see TDD. They might not see the way, the flow of time that caused that. But they will certainly notice whether or not they can read them. So in other words, I want to separate the way from the thing. And so good unit test, guts, is a really good way of looking at it. So this is the question. Have you landed somebody else with some nasty, unmanaged technical debt in the test base? But obviously, good is one of those words that doesn't have an intrinsic definition. You have to go out and say, this is what I mean by good. OK, so this morning, I highlighted the first abstract data type stack, Barbara Liskov, 1974. So let's jump to the present, and I'm going to do this one in Java rather than Clue. And what we've got is it's a generic stack, and it's just it's got depth, top, push, pop, and it's a strict pop. It just does void. We're not going to worry about any of the other complexities. And so how do we go about testing this? For a lot of people, there's a kind of intuition of oh, well, what I'll do is I'll just test each method, because that's how you do it. And it's just well, not really, no. And there's a number of things we can do to improve this straight out the gate, because we are clearly repeating ourselves. We already know it's a test. Don't tell the reader what they already know. Test construct. I know it's a test because this is probably in a test directory. I can see @test in front of it. So people say, OK, I'll take a step back here. I see that this is a little bit naive. And then they come up with all kinds of exciting variations. Constructor is correct. Oh, you surprised me. I thought you were going to test that it was broken. Depth is OK. Top is working. Push works. My favorite that I saw last year. Pop works as expected. What are you expecting? I mean, that's the point, is that we are teased, but we are not told. And it's just yeah, OK, we can do better than this. And then sometimes people go, well, there's the can-be smell, the can smell and the has smell, which is basically, guess what? It's got a constructor, because I'm saying it can be constructed. It's got a depth method, because I'm saying has depth. Yeah, I mean, I'm adding words, but I'm not really adding much more meaning. And then we get really pedantic, and we say, well, technically, an empty stack doesn't have a top. Technically, you can't pop an empty stack. OK? Sometimes has a top. Can sometimes. Oh, wow, you're really helping. OK, this is not helpful. We're adding more words, but we're not adding more meaning. And honestly, in the Java space, people love to add words without meaning. Oh, yeah, we'll make it this long. That's really helpful. No, honestly, I'm getting neck ache here. So let's talk about what it is. Let's have a discussion. Let's specify this. A new stack is empty. An empty stack throws when queried for its top. An empty stack throws when... We're answering all of the questions. We're simply just stating, here are the behaviors, here are the capabilities, the properties, the activities we can engage in. Then, let me just change the size here, because I'm going to do something that normally gets, from a Java point of view, throw me out the building. Underscores. Because there's a number of reasons for this. One, we are not naming ordinary methods. This is not verb phrases. We're not naming classes. This is not noun phrases. We're using whole sentences. These names are never going to be used elsewhere in code. The only reason these names exist is to be right there and to appear in a diagnostic. That is it. And these are full statements. They're going to be long. But also, thanks to me pushing this naming style for a few years, JUnit 5 even has a simple transformation. Display name generator replace underscores. So, in other words, it reads like a normal sentence. So we're getting something very literate out of this. I've also shifted the name to spec, a term that I originally got from BDD and Daniel Terhorst North, because I suddenly thought, actually, that's the right way to think about it. I am writing a specification. And we can adjust this. We can recognize commonality. Some of these names are long, but let's organize it by state. A new stack is empty. An empty stack throws when queried for its top, throws when pop. We can group things. Grouping and nesting, these are the simplest yet most powerful, enduring tools from a block structured perspective. But we can also support it directly. We can actually reflect that in the test. We can actually reflect the state model. So that is what I mean by guts. I hope that's been useful. You're off to revisit some tests? Excellent. Thank you. Right, so what we have is, while we're on this, one of my favorite sayings from Emile Auguste Chartier, nothing is more dangerous than an idea when you have only one idea. There are many ways to approach testing. Do not get stuck into what you think is the one true way. Embrace many possibilities. So I'd like to welcome on stage Emily.
Thank you. Thank you. Oh, when I get the clicker. Yes. So I'm very happy to get a little slot to talk about my thing. And I'm going to talk about approval testing, which is one of the two things I contributed to the book. And I want to talk about this because not enough people know about approval testing. But I think you've probably recognized something like this. This is a unit test that I'm in the middle of writing, and you can tell I'm not done because it doesn't obey Kevlin's rules. It starts with the word test. Anyway, so imagine I'm just developing this test, and this function call, doesn't matter what it does, but you can see that it returns a string because I'm asserting that it's returning an empty string. Now, the thing is, this thing doesn't return an empty string, or it won't when I've developed it. It's going to return something much more interesting than that. But while I'm writing the test, I've just put a placeholder there of an empty string, knowing that that will mean I will get a really nice test failure message that will show me what I actually got, and then I can work out if that's what I wanted, and if it is, I can just copy it from the test output and paste it into my code in place of that empty string, and then I'll have a great test that works and passes and checks the right thing, and I'm done. Have you done that? I'm imagining a lot of you have. Yeah. So this is what I would actually call approval testing, only without the tools. So that process that you go through, looking at the output, and when it looks right, and you're like, yeah, that's what I want, I approve that, I'm going to keep that in my test. That's where the name comes from, approval testing. It's about approving a result. And these days, some people know this by the name snapshot testing, and some people know it by the name golden master testing. And which of those names you know might give me a clue as to how old you are. Because the snapshot testing is what Jest calls this kind of technique, which is quite a new test framework, relatively speaking. And golden master is from, like, in the days when we bought music on CDs. The CD that you bought in the shop in the 90s was a copy of the Golden Master. So I don't like either of these names for this style of testing. I think approval testing is much more evocative of what it is, so I just include these in case you were wondering. Now, a test would usually have three parts: arrange, act, assert, or given, when, then. And the difference with an approval test is that you're changing the way you do the assertion. We replace the assert with a print diff. And that diff is the important part where you can see what you approved earlier against what you got. And if there's a bug, you should be able to see, oh yeah, it's not giving me the right thing. and you go and fix the bug. Or if actually you've changed the behavior and now the thing that you're looking at and saying, actually, I approve that instead. And the diff is what gives you the information. So it's important that the test is producing a text that works to diff and lets you make that decision. Do you approve the result? And the print step there is for if your test is not actually going to produce a string, it's producing some kind of complex object, the printer is the code that takes that object and turns it into a string that is suitable for that diff. So an approval test, you could say it has 4 parts: arrange, act, print, diff. Now, if you're going to do this kind of testing, I do recommend my biggest piece of advice: get a proper approval testing tool. Do not do this in JUnit by pasting the strings into the source code. I think that is a error-prone, poor result, and there are very good tools out there, and if you use them, you get the benefits of all the experience of the people who invented the tools. For Java, Llewellyn Falco's tool, approvals.java, is very good. And it does things like help you to store the approved text in a separate file, not in your source code, although it can do that too. It'll help you to see the failures really well in the diff tool in a convenient way, and it will help you to bulk update when you've got a lot of failing tests, failing for the same reasons. So I do recommend getting a tool. And then you'll well, when should I use this and not ordinary tests? Legacy code. A lot of people use this legacy code because it's very convenient for creating characterization tests. But you can also use it very profitably where your output is already text, like JSON or XML, or when you've got a very visual kind of output or two-dimensional output. You don't have to do it with text, actually. You can do approval testing with images, but text is usually more convenient. And the last case is if the output is actually a really complex, big object, it can be much easier to write a printer than it is to try and query it and find the bits you need to assert. So that's often a good use case for approval testing. Thank you.
Right. I think you've got the clicker. Oh, clicker power. We're going to be Dave.
We're Dave.
Yeah, he gave us these, so continuous delivery. There we go. Yeah, we're Dave. I'm going to be bad Dave. You're going to be good Dave.
Okay.
And we're going to talk about writing readable code. So,
do you want me to click?
Yeah. So Dave says, we've all heard that good code is readable, but what does that really mean? I mean, most people don't sit down and go like, I'm going to write something unreadable. They just like, of course my code is readable. It's self-documenting. I can read it. This self has no problem with it.
Except for next week when I have way more problems with it because my memory is so bad. So I'm going to tangent because that's what we do. One of the things I think that we don't always recognize as developers is that the code has 2 end users. One is the machine, which will run the code, but probably more importantly is the other developers who are going to read that code. So it's not so, the machine will understand what the code does. It's much more important that we concentrate on the other reader of the code, which is other developers.
Yeah, so code is an act of communication. So, Trisha, here's some code. I'm really proud of this. I've put this together. It's just a little bit over 400 lines. And, maybe I could trim it down to maybe 400, because that's a nice round number. I've used meaningful names, like CI. I mean, it's really close to CD. Unlikely. I've got logic in there. What more do you want? And I've got, the important stuff, the 361 lines of code that's going to be on the main path is first. And then I've got another 45 lines of else. And we all know about else, because I talked about it this morning. So I think, how do you feel? I mean, does it look good to you?
Well, I'm not super happy, I must admit. Well, that sounds like Trisha. What would Dave say? Dave would say, so, what you need to consider...
I think it'd be deeper and it'd be a little more judgmental.
So, have you thought this through? You have to consider that... I'm trying to be deep, Dave. I'm a bit too much of a girl. You have to consider that you won't be able to read the else when there's 361 lines of code in the way between the if and the else. And the if and the else are not close to each other, even though they're actually related. So what you really want to be doing is you want to get rid of those 300 and whatever lines of code, but you put them somewhere else in a method, and you call it what it is. What does that method do?
It creates a connection.
Why don't we call it a method, create connection?
Oh, And the first one is like, if there's no connection, as opposed to unlikely. I mean, unlikely was nice and short.
Unlikely was nice and short, but humans, so computers can 100% read negations. That's absolutely fine. But humans are not good at reading negations in code or in, I found this as well with writing actual prose. In prose, people don't understand the no. So let's flip it on its head. We can call that, if there's no connection, then it reads like a sentence. If there's no connection, then create the connection.
Okay, I get it. Okay, yeah.
All right, good. I'm glad you learned your lesson, young man.
Yeah. Work on that. Just say the young bit again. I was feeling really good about that.
What's next? Right, so the point, I don't know. We haven't practiced this very much.
No. The point here is that Dave's article, there's a lot more detail, but we've kind of boiled it down. There are 4 elements here. Simplicity is obviously one of the ones that we value, and it's to do with the number of moving parts. It's to do with the number of things that you have to absorb. And lines are things, indentation is things, methods are things, all of these things. You're trying to keep them in balance. You're trying to find the right balance there. But there is this idea that the pieces should be small. And you can put a number on it. You can do something with that. And we can debate the numbers, but let me tell you, 400 is definitely not small.
Definitely too much. When Dave Farley interviewed me to go and work with him at LMAX, at that time I was big on commenting my code, which actually is another piece in 97 things. I was big on commenting my code, and I was like, I believe in code comments because I need to tell future me what this was all about. And he was like, no, we don't comment our code. And I was like, he said, we write methods that does. And so he's like, let's assume that this is the code that you would normally comment. Let me show you that I can turn that comment into the method name. And I was like, oh, that makes way more sense. And with refactoring tools, you can easily change it when the thing changes.
There's somebody who's been talking about IDEs. I think she's got a real inside track on that.
That was the third thing, refactoring. Thank you.
We got there. This is eventual consistency. You've heard a lot about eventual consistency. We totally prepared that.
and Martin's here and everything. Yes, I meant refactoring in IntelliJ IDEs, one of my favorite features. Great. Name the pieces for what they do. And the other piece, which we didn't really cover in the code sample, is to automate your coding standards. So that if you don't want your methods to be this long or this many lines, then make sure that's automated so your CI goes, no. 347 lines is too much. 20 lines is too much.
I was really attached to those lines. Part of me was in that.
Dan says, don't get attached to your code.
Oh.
Right, so what's next? Right, Holly, you're up. Thank you.
I'm going to take that applause as well done for getting up those stairs. And I'm going to continue by talking about other things that are challenging. So let's talk about garbage collection. When Java was introduced, people had a lot of things to say. It was interesting for that brief period of time when it was introduced. And one of the things people said was, this language has garbage collection. That's terrible. That's going to make all of the developers stupid. Because there was this idea, it's an extension of the idea that people had that you're only a real developer if you write assembler. If you're writing this C stuff, you're soft, you're intellectually weak. And then people kind of got over that. But then Java came along, and there was that same idea was repeated. If you're not manually managing your memory, you're stupid, you're intellectually weak. We'll come back to that. Because this idea is wrong in basically every single way, except for maybe the fact that manually managing memory is hard. Because the thing is, if you try and manually manage your memory, it's going to take you a really long time. One of the things that people like about the Rust language is that it doesn't have garbage collection. But some bright sparks took Rust, and they added in a garbage collector. And what they found was that people worked. And they could complete a problem in a third of the time because of the help of the garbage collector. Garbage collection is a really big productivity aid. The other thing is that garbage collection is a really big correctness aid. We've had the quote a few times that any blank contains a buggy half implementation of blank. And this is definitely true with garbage collection. If you don't use automated garbage collection, you will end up implementing your own garbage collector that's worse, and it will take you a lot of time to do it. And then finally, what have you achieved for all of this work to make your difficult, buggy garbage collector? Your code probably isn't even any faster. We tend to think of garbage collection as a necessary cost. Often it's not even a cost. And we said yesterday that information on the internet lives forever. Information in books lives even longer. And so you can still get books that say, the way to tune garbage collection is to look at your garbage collection pauses and make the amount of time spent in garbage collection pauses as short as possible. This is really terrible performance advice. If you do this, you risk making the metrics that you actually care about, like what is my latency, what is my throughput, you risk making those metrics worse. And let's look at why this might be, because it is a little bit counterintuitive. Garbage collection is automated memory management. A program does a bunch of things with memory. One of the things it does is access it. This is actually the bulk of your program's interaction with memory. You want that to be fast. Another thing a program does with memory is allocate it. You want that to be fast. And then the final thing is freeing it. And this is where we see that visible cost of garbage collection. But garbage collection can actually make the other two pieces much faster, which will have a big impact on your program. And so when you think about optimizing your garbage collection, what you really need to be doing is thinking holistically about what kind of workload do I have? How does garbage collection work, and how will my workload interact with that? So with garbage collection, when your program is accessing the memory, there are caches. You don't ever want to go out to the RAM. That is glacially slow. Instead, you will probably get the memory that you care about from the cache. If you're unlucky, it's in the level 3 cache. That's still pretty slow. It might be in the level 2 cache, but if you're really lucky, it's in the L1 cache. That's where it's fastest. But each cache is smaller. And so what this means is that when your program accesses memory, things that were next to the thing you just accessed will also be in the same cache line, and so you can access them quickly. And so what this means is that you want your memory to be as compact as possible. And particularly, you want things that are used at around the same time to be physically co-located. And this is called object locality. So if you want to sound clever, you can talk about object locality. The other thing that your program will be doing is allocating memory. So when you allocate memory, you need to find a place in the heap that is big enough for it. So what it will do is it will look for the first place. Nope, too small. Look for the second place. Nope, too small. Look for the third place. Nope, too small. Look for the fourth place. Too small. Eventually we got there. This is really slow. So what you want to be doing is having that compact heap so that when you need to allocate something, you just go, oh yeah, it fit in the first place I looked. There was no problem. There are two ways, roughly, that garbage collection can work. The first is what's called mark and sweep. And so what it will do is when there is a problem, when it decides it needs to do a collection because it cannot fit that big object anywhere in the heap, it will go through all of the objects and it will look at which ones are still in use. That's tracing. It says, okay, yep, gonna keep you, gonna keep you, gonna keep you. Then it goes through everything else that's in the heap and says, okay, I can get rid of you, I can get rid of you, I can get rid of you. If there's not much garbage, this is pretty fast, but it depends. And then eventually you can fit your object into the heap. There's another form of collection called copying collection. With copying collection, what we do is we keep another area of the heap just free. When we do that tracing process, If something is still in use, we copy it. If it's not in use, we never even see it. Garbage costs us nothing. And so what that means is when we do a collection, as long as most of what we collected was garbage, the collection has a really low cost. So this is potentially very good. And you can see as well, that heap is really compact at the end. So allocation is quick. Memory access is likely to be quick. That doesn't mean copying collection is always the right answer. It definitely isn't. But it's worth being aware of those ergonomics when you're thinking about how to optimize. So, to wrap up, you probably do want to be thinking about garbage collection. You probably do want to be doing some tuning of garbage collection for your workload. But whatever you do, don't just tune garbage collection by trying to reduce the overhead of GC. You need to take that bigger holistic picture and look at the things you care about, which is how fast your application actually runs. Thank you.
All right, we only have 4 minutes to go through the next two things, so I'm going to try and do this in 2 minutes. So Kevlin wrote Name the Date, which is great because I wanted to write something about how hard dates are, and Kevlin did a really good job of doing it, so I didn't need to write that. And basically, dates are hard. The end. No. I mean, they are. When I worked with Dave Farley, we had loads of automated acceptance tests, and we had a really smart team that did all the right things. And because we were working in England, which for 6 months of the year is on UTC, every time summertime finished or started, half the acceptance tests would just go wrong because we forgot about time zones. Never mind. Totally easy. Okay, so Kevlin, the reason I really like Kevlin's piece is because he rips off Pride and Prejudice. It is a truth universally acknowledged that a single programmer in possession of the belief they understand dates and times must be in want of a code review. Date and time is hard. Let's take an example from java.util.date. So, which I hope no one's using anyway, because it was deprecated about 3 minutes after they wrote it. People are still using it. So java.util.date is not actually a date. It is a date and time. GetDate does not get the date. It gets the day of the month. Okay. And GetDay, does it get the day of the week, the month, or the year? I mean, who knows? They just kind of randomly named these things just to make our lives more difficult. And if we take a significant date, for example, this is actually very good, given that we had the moon presentation.
To the moon, yeah, that's awesome.
The other day. So Apollo 11 landed on the moon at 17 minutes past 8 on the 20th of July, 1969. And if you do get time on java.util.date, it returns you a minus number, because, of course, the date counts from 1970, right? So that's fun. Get date returns 20. Well, it was the 20th of July. That makes sense. And get month returns 6. Okay, because July is the 6th. No, it's not the 6th month of the year. No, because months are 0 indexed. Great, that's easy. And get year returns 69, not 1969, because, you know, apparently 2 more characters, even in this day and age, is just too much to hold in memory. So yes, oh, there we go. So that's it. So date and time is very difficult. Do take care when you're using date and time. And also use more modern things for doing date and time, because what's it called? Java.time.date time local.
It's time. Just
Java.time
look
is
at that
way
package.
better. The end.
Thank you. Yeah, I mean, the point there is that if you think you understand date time, you're probably wrong. If you think you don't, you're probably right. Okay. So I'm going to cover Trisha's piece, because we've actually gone on to quite a lot of technical topics, but this book actually cuts through. It's what a Java programmer should know, and actually I'd say 50% of the advice probably works for any programmer. It's not a guide to Java. It's what I, as a professional, might need to know. Technical interviewing is a skill worth developing. Trisha points out our industry is horrible. This actually gets italics, you know, at interviewing developers. And given that some of us are the people responsible, take note. But it's a skill. You can learn it. And remember, the idea is that in many cases, the interview is not a scenario that is actually done to be realistic. It's not actually often about writing code and what do you like to work with. People often go through the same kinds of questions, and they're trying to filter. So the benefit of this is that you can learn the answers to some of these. And no, it's not cheating, because what you're doing is it's like a dance. It's a choreography. If they make that move, you make this move, okay? And you are learning to dance, and dancing is a skill. So here's 3 examples. Multi-threading gotchas. I think one of the most important points that Trisha makes is if they start asking you about really weird stuff, that tells you they're not really asking you about really weird stuff, is we have these terrible problems. Most of the time when people are having this kind of experience, that's what they're saying. You want to direct them to the utils for this. There's a whole load of stuff there. Okay, you want to be dealing with fork and join. You want to be dealing with the higher level utilities. You want to be encouraging immutable objects. They will possibly ask you about, we want you to be a compiler. They'll never say that, but we want you to be a compiler. And it's one of those things of like, well, I've already got a tool that does that, but there is the idea that, yes, they will try and throw gotchas and bits and pieces, and can you recognize that these are all learnable? And a lot of people will have a kind of classic computer science education and lean back on that and start talking about data structures. The thing is that Java comes with a somewhat well-provisioned library in this. So the real goal of this is not to kind of roll out your university linked lists and to worry about that, is to basically approach those problems from the perspective of here is what we already have available to us. Let's take advantage of it. Become knowledgeable about the library and rest on that. But the other thing is there's another part of this interview. When we say we're bad at interviewing, it's a two-way thing. Find out both by reading between the lines, but also by directly asking, what is it like to be there?
Nice. I think that's all the time we have, but thank you. Give them a hand.
Very much.
Thank you.